We're going to be talking about logarithms, continuing, I should say, our discussion on logarithms. And here in 4.5, that is with log rules. So I know that they were reviewed in the video, but I want to take a minute to talk to you about log rules. So the log rules are inverse of exponential rules because logs and exponentials are inverses. So if the exponential rule is to put these together, when you multiply, you add, then the log rule is to put these together. When you add, you multiply. Okay? The exponent rule is when you multiply, you add. The log rule is when you add, you multiply. And so the division rule functions in much the same way. X to the 6 over x to the 2. In order to put these together, when you divide, you subtract. And with logs, in order to put these together, log of, I don't know, 15. When you subtract, you divide. Okay? So the exponent rules are when you multiply, you add. When you divide, you subtract. The log rules are when you add, you multiply. When you divide, or when you subtract, you divide. And again, those are inverses because these functions are inverses. So I hope that makes sense. So in keeping those properties in mind, if I wanted to write these as a single logarithm, well, when I add, I multiply. So this would be log base 4 of 8x to the 8th times 7x to the 8th, which would be log base 4 of 56x to the 16th. Okay? Now for this next one, if we have log base 4 of t plus 10 minus log base 4 of t plus 1 minus 7. So this would become log base 4 of t plus 10 on the top, and then t plus 1 and t plus 12 on the bottom. And I feel like that one gets people sometimes. So you could always think of it this way. If I GCF out the negative between these two, it would be that these two are being multiplied and they're on the bottom. So really another way to think about it when you have a bunch of stuff like this is that anything that's positive goes in the numerator and anything that's negative goes in the denominator. Okay? So that's condensing. The other thing that we do is expand, which is basically the opposite of what we just did. So here, if this is multiplying, then when I pull them apart, it will become addition. T to the 11th plus log base 8 of the cube root of z to the 11. Now, there's one more rule here that we need to put into play, and that is the rule that says when you have an exponent, you multiply. So just like when I have an exponent to an exponent, I multiply. The log rule is that if I have a log to an exponent, I turn that into multiplication. Okay, so the first one's easy. The 11 just becomes a coefficient. Now for this one, a quick note that the cube root of z to the 11 is the same as z to the 11/3, where the index on this root is what goes in the denominator and the exponent goes in the numerator. So an extra side note that if you had something to the 1/2, that's the same as the square root of that thing, because the index on a square root is 2 and the exponent when we don't write it is 1. Okay, keep that in mind. this is the cube root of z to the 11th, of z to the 11th is the same as z to the 11 thirds. So this 11 thirds is what I'm going to bring out. Like that. Okay. So then let's take a look at the next one. This would be the ln of x to the 10 plus the ln of the fourth root of t minus 1. And then since this is in the denominator, it would be minus the ln of 9r minus 10. And then the last thing we need to do is the same thing we did here. So the 10 would come out. So a fourth root is the same as to the 1/4 power, just like a square root is the same as to this, like 1/2 power. So the fourth root would come out as a 1/4. And then there is no exponent here, so. Okay. So here, I'm not going to worry about all this for a second. I'm just going to expand this. Okay, let's expand it as much as we can. This would be log base 9 of x to the 7th plus log base 9 of t to the 6th minus log base 9 of log base 9 of y squared. And then that would become 7 times the log base 9 of x plus 6 times the log base 9 of t minus 2 times the log base 9 of y. And that's my expansion. Now, I'm going to look at what they gave me. So I know that the log base 9 of x is the same as negative 6.34. So this is 7 times negative 6.34. The log base 9 of t is the same as 5.01. So that's 6 times 5.01. The log base 9 of y is the same as negative 5.97. And now this is a calculator problem. I was like, mine's here. I know it's here. Where'd my calculator go? I just saw it. So I have 7 times negative 6.34, 6 times 1. Ooh, I forgot my addition sign. That would be bad. All right, let's try it again. 7 times negative 6.34 plus 6 times 5.01 minus 2 times negative 5.97. So that's my final answer. Okay. Awesome. Let's do the exact same thing. So first of all, here, everything has the 9th root applied to it. So I'm going to take all of these exponents and I'm going to put them over 9. Because remember, we just said that the conversion is that it's your exponent is your numerator and your root is your denominator. So this is the exact same thing as log base 3 of t to the 11/9 over y to the 5/9 r to the 12/9. Okay? So instead of that 9th root over all of them and forcing them to stay together, I'm going to put all of my exponents over 9, And now we don't have that root holding everything there. Okay, so now I'm going to expand. This would be log base 3 of t to the 11/9 minus log base 3 of t to the 5/9, and then also minus log base 3 of r to the, I'm not going to write 12/9, 4/3. Because 12/9 reduces to 4/3, right? Listen, if you would have left it at 12/9, nothing would have happened to you. You wouldn't have died, I promise. I just didn't want to. And now, just like above, my next step is going to be to move those exponents out. So this is 11/9 times the log base 3 of t minus 5/9 times the log base, were those both t's? Why? Why did I put a t there? That's weird. Why? Minus 4/3 log base 3 of r. And now again, just like in the problem above it, I'm going to replace what I know. Log base 3 of t is 11.09. Log base 3 of y is negative 11.7. Log base 3 of r is 15.69. And now I'm going to grab my calculator. So 11/9 times 11.09 minus 5/9 times negative 11.7 minus 4/3 times 15.69. No, they probably wanted 2 decimal points. So let's say negative 0.87. I only did that because I was curious. Okay. Now, when you're putting these in your calculator, how you put it in is going to depend on which calculator you have. So if you have a TI-83, you would put this in as the log of 25 divided by the log of 22, where your log button is right here below x squared. So you would do the log of 25 divided by the log of 22. Okay. Now, if you have a TI-84, you can do that. That's an option for you. Or you can press math and scroll down until you see log base. And then what that does is it gives you this little box right here that you can fill in with the base. And so then you would do 22 and 25. Like this. Math. Scroll down until you see log base. There it is. 22, 25. And notice we got the exact same thing both times, which is good because I would have been concerned if I was telling you to do something and that you'd get the right answer either way and that those answers were different. So again, how you do this is dependent on what calculator you have. Everybody can do this. If you have a TI-84 and you prefer, you can do this. So 1.041, they wanted how many decimal points? 5. So 1.0413, that's 1, 2, 3, 4. That would be a 6. Okay. I like the log rules, but I think they're pretty easy to work with as long as you can remember their relationship to the exponent rules. Once you start making those connections, these rules are pretty easy to apply.